Hello everyone, welcome to this video. In this video, we are going to explore volume by cell method. First, we are going to look at the definition. Suppose y equal to f of x, this function here, and y equal to g of x, this one here, are two continuous functions on the interval from x equal to a to x equal to b, with f of x greater than g of x, f of x is greater than g of x, and both of them are positive. If R, the region, this one here, if R, the region bounded by the graph of the functions, these two functions, and the lines x equal to a and x equal to b, is revolved about y-axis. So here, we are revolving the region about y-axis. Then the volume of the solid formed, according to cell method, is given by this formula. If we are revolving about y-axis, then we integrate with respect to x. And the volume is given by this formula, v equal to integration from a to b, 2 pi x, then f of x, which is the function far from the x-axis, minus g of x, which is the function closer to x-axis. We are integrating this difference with respect to x. But if we are revolving the region about x-axis, if we revolve the region about x-axis, in that case, we'll integrate with respect to y. And the formula will be similar, except this x is replaced by y. And in place of function of x, we have function of y, phi of y. And in place of this function of x, we'll have this one, the function of y, as psi of y. Note that phi of y is the function farther from the y-axis, and psi of y is the function closer to y-axis. Now we are going to look at the examples where we'll be using these two formulas. Example, the region R in the first quadrant enclosed by the graph of the functions y equal to sine x squared, the x-axis, and the line x equal to square root of pi over 2 is revolved about y-axis. Find the volume of the solid formed using cell method. So first, we are going to draw the region which is in the first quadrant. So let's begin that. For that, this is my x-axis. That's my y-axis. We are going to label that y, O for origin, and then x there. Here the functions are x equal to, there is one function actually, the function is y equal to sine of x squared. So if we draw the graph will be something like this. This is y equal to sine of x squared, the x-axis, which is already here, and the vertical line x equal to square root of pi over 2. So now let's draw the vertical line. So that is the vertical line, x equal to square root of pi divided by 2. So the region R is here. This is the region R. And what we are doing here is we are revolving this region R. Okay, we are revolving the region R about y-axis. We are revolving this region R about y-axis, and we want to find the volume of the solid formed when we revolve this region R about y-axis using cell method. So in cell method, when we are revolving about y-axis, we'll be integrating with respect to x. So let's write down that formula. By cell method, volume V is equal to integration from a to b, because we are integrating with respect to x, integration from a to b, 2 pi x, f of x minus g of x, and this is integrated with respect to x. So volume will be equal to integration from a to b. We are integrating from here x equal to 0 to x equal to square root of pi over 2. So 0 up to square root of pi over 2 then 2 pi x multiplied to f of x minus g of x. F of x is the function which is far from the x-axis. So this is the function which is sine x squared then minus the function which is close to x-axis. In fact, this is the function which is y equal to 0. And we are integrating this with respect to x. So if we write it neatly, it is integration from 0 up to the square root of pi over 2 of 2 pi x sine x squared. And in this integral, we can see that the derivative of x squared, which is 2x, is also here in this integral. So what we can do is we can integrate this using u substitution, where u is equal to x squared. So let's do that. Let u equal to x squared, which implies du equal to 2x dx. So if we make that substitution, volume will be equal to integration sine x squared. Pi, I'm going to keep that as it is. Sine x squared is u. And then we have 2x dx, which is du. This integral here is in terms of x. So these are the limit of integration in terms of x. Now our new integral is in terms of u. So I also need the limit of integration in terms of u. So what we'll do is, here x is 0. So if we plug in x equal to 0 here, u will be equal to 0 squared, which is also 0. Similarly, this upper limit is x equal to square root of pi over 2. So if we plug in that, u equal to square root of pi over 2 squared, which is just pi over 2. So u is pi over 2, or the upper limit is pi over 2. So we change the limit of integration, we change the integral in terms of u. Now we can easily evaluate that integral. V equal to pi, integration of sine u with respect to u is negative cosine u. And we need to evaluate this between 0 and pi over 2. Between 0 and pi over 2. So volume will be equal to pi multiplied to, in order to simplify this, we plug in the upper limit first. The negative cosine pi over 2 minus, we are subtracting our negative, so it will be plus. And if we plug in lower limit, that will be cosine 0. The volume is equal to pi negative cosine pi over 2 is 0 plus cosine 0 is 1. The volume is equal to 1 minus 0, that's 1. 1 times pi is pi. The volume is equal to pi cubic units. In this example, we revolve the region R about y-axis and we use cell method to find the volume when that region is revolved about y-axis. The volume of the solid formed when that region R is revolved about y-axis. We'll look at one more example. Okay, here is the example. The region R in the first quadrant enclosed by the graph of the function y equal to square root of x. Here is that function y equal to square root of x. The x-axis, which is here, and the line x equal to 4, this vertical line, is revolved about x-axis. We have to find the volume of solid formed using the cell method. So whenever we are revolving the region R, this region R about x-axis, and we are using the cell method, we have to integrate with respect to y. So first, we are going to write that formula. So we have the formula, so let's write that. We know by cell method, volume is equal to, as we are integrating with respect to y, it is integration from c through d, 2 pi y, then phi of y minus psi of y integrated with respect to y. In this case here, the lower limit for y is 0 and upper limit is 2. So we are integrating from 0 up to 2, integrating from 0 through 2 pi y. And phi of y and psi of y, these are the function which is close and far from the y-axis. So over here, as we go, the function which is far from the y-axis is x equal to 4. So the first value here is x equal to 4 minus, for this reason, the function which is close from the y-axis is plus 1, but we want to write that function in terms of y. So here we have y equal to square root of x, that is in terms of x. If I want to write in terms of y, we need to find the value of x by squaring on both sides, so we get x equal to y squared minus y squared dy. Now we need to integrate this, but before that, let's take that 2 pi out. Integration from 0 to 2. If we multiply by 4, that will be 4y minus y cubed integrated with respect to y. The volume is equal to 2 pi. If we integrate 4y, that will be equal to 2y squared minus, if we integrate y to the third, it will be y to the 4 over 4, which needs to be evaluated between 0 and 2. Between 0 and 2. The volume is equal to, if we plug in upper limit, 2, then it will be 2 squared 4 times 2 is 8 minus, if I plug in 2 here, 2 to the 4 is 16. 16 divided by 4 is 4. Then minus, if we plug in the lower limit, this will be 0, this will be 0, meaning everything in the parenthesis will be 0. 0 times 2 pi, that will be 0. So we get volume equal to 8 minus 4 is 4. 4 times 2 is 8. So that is equal to 8 pi cubic units. 8 pi cubic units. So the volume, well, revolving this region R about x-axis is 8 pi, and we calculated that using cell method. Remember, in cell method, when we revolve about x-axis, we integrate with respect to y. And if we revolve about y-axis, we'll integrate with respect to